jack output has a null dereference here. If you look, this in buff here is gotten from this function, and then we dereference in buff here. And so there's a null dereference that crashes the program. It isn't exploitable, of course. And to reproduce this, you just run this code here. And I think MuseSeq has got a bug in it that makes it do a null dereference as well. So let's look at the relationships to try and figure out what this is, what's going on. So you have inBuff is returned from this function, and it uses all these to calculate. And then you have this context variable, which I showed you, that's passed in, and that's related to this function here. And then that is set to this thing here. It's actually referenced. And so you can see here this jack context. It does a malloc, and it does a memset. And actually, it makes perfect sense that this is a very valid relationship. There's nothing wrong here that's obvious in the relationship. In fact, that's quite true. The map that I made wasn't useful at all. What was useful was another relationship, and that relationship showed that the function writeJack and the function destroyJack both weren't ever called. And so that gave me the assumption that something might be going on strangely. And in fact, that's what happens, is that you destroy Jack, and then you write to Jack. And that's a bad thing. That's what's going on there. And let's think about solving all null pointer dereferences for a moment. If you look at this, this is an interesting relationship. It's not actually true to what's going on, but it kind of shows you how many things are involved, how many functions, how many other variables. And so you have plenty of variables that are influencing this. And so you have difficulties. So my thought is that if you take each dereference and then follow where it's passed from, right? There's other ways to do it. If you were to instead look at all the allocations and deallocations and then follow them to their dereferences, you can also do that. Or if you want to try to vet every function in a project by making sure that all the calls to it are valid, then you can try that way. So this is kind of what my program does. It finds a variable and sees that it was set to null. It's also set to this variable, and it's also set to itself dereferenced, which is pretty common. It's kind of interesting. I think it's a linked list. I'm not actually sure what's going on there, but we can see it's passed from this function, which has another variable which is passed from this function, which it's also set to null, and it's cast from this variable. And so then we can see here it was passed in, but there's no function that actually calls that function. We get another relationship that doesn't make sense. I actually found an interesting function that does a for each in C that's actually calling this function, this print tree atterfunc. And so let's move on. If you think that perhaps if var is the solution to null derefs, you aren't really right. There's a lot of ways to defeat if var. If var introduces more complexity to your code, and so that's not really the way to go about it. I could probably go on more, but I'm running low on time. So my plan is to vet entire projects. I want to vet BlueZ and then publish the results. And I think that'll improve the quality of software as well as give other people the chance to prove me wrong. It'd be really nice to be able to say I can use Bluetooth without worrying about buffer overflow. And I think the way I'm going to do that is by figuring out every relationship that the project does. And there's going to be a lot of manual parts to that. That's an assumption we have to make. But we can, I think we can totally do it on the entire open source stack using static analysis. So thanks to my friends Morgan, the Neg9 crew, the people who wrote BlueZ and Timidity, Hikari and all the other organizers of Toorcon, I really appreciate it. And of course the viewers, this would not have happened without you. Thank you very much. Questions? Nope, I wrote a piece of software and I actually sell that piece of software that generates graphs based on anything you write. It's really easy to create. If you'd like, I could show you. It's called Small Wide World.
Are you doing analysis on the binary or on the source code?
Source code. Source code's a lot easier.
So how does your approach compare with commercial static analysis?
Right. There's a lot of things that I'd like to think that I'm doing that they aren't doing, but I'm not actually sure. I haven't put too much time. I looked at Splint and there's one CPP something. Anyone know of that software? Anyways, those pieces of software are useful, but they don't. It doesn't seem like they follow the relationships the entire way to the allocation. I might be wrong. What's that?
Did you analyze any other software?
Yeah, I've been, I analyzed BlueZ, Timidity. I did a bit of work on NTP, and my coworker Morgan did some work also on NTP and MDNS. We're just working our way on things that are interesting to us. Any comments? Any other people using static analysis for this? It seems like everyone I talked to was working on static analysis in one form or another. So. Thank you.